We're back with our indifference curves and our budget constraint, and we're getting ready to derive the consumer's demand curve. Remember what we did last time. We showed that if you have a set of opportunities created by your income and prices, and a set of preferences, you're going to look for the most satisfaction you can get, given your constraint. That point of maximum satisfaction will be where your budget constraint touches the highest attainable indifference curve. Now, what's going to happen if your opportunities change? How will your behavior change if the constraint changes? In particular, how will Chris behave if we reduce the price of toys? Let's cut the price of toys in half, from $3 a piece to $1.50 each. What would Chris do in those circumstances? First, let's show in our graph the new budget constraint. With the price of $1.50 each for toys, the vertical intercept remains unchanged. We haven't done anything to the price of snacks or to Chris's income, so if he spends all of his income on snacks, he can still afford 12 snacks. However, if he spends all of his income on toys now, at a price of $1.50 per toy, he can afford to buy 8 toys instead of 4 like before. So here is Chris's new budget constraint. Our blue line here represents his opportunities with an income of $12 and a price of toys of $1.50 each. What's Chris going to do? As usual, he's going to look for the combination of toys and snacks that gives him the most satisfaction subject to this budget constraint. And that means looking for the highest attainable indifference curve. Well, it's clear that the highest attainable indifference curve in this picture is the one that's labeled U1. And the combination right here, 2, 4, 6 snacks and 2, 4 toys, that is 4 toys and 6 snacks, this particular combination represents Chris's optimal choice. Let's make sure that point's attainable. Of course, it's on the budget constraint, so we know that it is. 4 toys times $1.50 each gives us a total of $8, and 4 snacks at $1 a piece gives us a total of $4. 4 plus 8 is 12. Once again, Chris satisfies his budget constraint. How do I know that this particular combination is the best Chris can do? Because it represents a point of tangency between an indifference curve and the budget constraint. This is the point at which Chris's marginal rate of substitution, that is his willingness to trade toys for snacks, is equal to the relative price of toys and snacks. That is what the market will permit. You always find the optimal point where the indifference curve is tangent to the budget constraint. That's always the best that he can do. So, even though there are other indifference curves that are way up here to the northeast, Chris can't reach them because he doesn't have enough money. Even though there are other indifference curves that are below, they're irrelevant because they intersect the budget constraint. They're lower. Chris can get to a high level of satisfaction, the highest he can attain, by finding the point where the indifference curve touches the budget constraint at only one point. U1 is the highest level of satisfaction he can get. Notice what I did here. I changed the price of toys, and I looked at how Chris's optimal choice changed. He buys more toys than before. Before he was only buying 2. Now that the price of toys has fallen, Chris buys 4 toys. What I'm getting to is a demand curve. When the price changes, the quantity demanded responds, and that's what a demand curve is. In the next lecture, we will put the indifference curve budget constraint diagram that we have here before us, we'll put it on top of another axis and use this apparatus to derive a demand curve. What we're going to be seeing is the foundation for the demand curve, that is, where it comes from using this more basic theory.